My name is Dr. Fuller. I would like to introduce you to the mathematical world around you. The ideas of rates and unit rates are helpful in many areas of life and work. They can be instrumental when we want to make comparisons. First, a rate is a type of ratio where the units are different. We use the word per to separate the values. For example, a rate could be traveling 10 miles every 5 minutes or 10 miles per 5 minutes. Another example is 7 loads of laundry for 3 people or 7 loads of laundry per 3 people. Because we often make comparisons between two things with different units, rates appear all around the world. A unit rate is a type of rate where the second value or the value after the word per equals 1. Examples you might be familiar with include miles per hour, the number of players per team, and the number of students per class. Each of these is a comparison to 1 hour, 1 team, and 1 class. Unit rates are beneficial when we want to make comparisons. When the second units are the same and both values are equal to 1, we can simply compare the first values of the ratio. For example, Kaji rides a bicycle at 25 miles per hour, and Rania rides her bicycle at 33 miles per hour. To know which person is faster, we simply compare the first values, in this case, the number of miles. 33 is greater than 25. We can see that Rania rode her bicycle faster than Kaji. Furthermore, we can find the difference between the two values to know that Rania rides her bicycle 8 miles per hour faster than Kaji. The problem is that many things in life are not provided in their unit rate form. This is where converting a rate into a unit rate becomes essential. I will begin with an example to demonstrate what is happening mathematically. Kaji says a 5-mile ride took him 20 minutes. Rania says she rode 8 miles in 25 minutes. Who was faster this time? To compare the two's speeds, I will make unit rates to make this easy. I will start with Kaji. I begin by writing his ratio of miles to minutes as a fraction. Our goal is to make the denominator of this fraction a 1. The multiplicative inverse property states that multiplying a number by its reciprocal gives a result of 1. However, if I multiply the denominator of a fraction by a number aside from 1, its value changes. Therefore, the value of the fraction changes as well, and I don't want to do that. What I need is an equivalent fraction. The identity property of multiplication allows us to multiply any number by 1 without changing the value. A fraction with the same numerator and denominator is equal to 1. I create a fraction using the reciprocal of the denominator. This fraction uses the new fraction as both its numerator and denominator. Yes, it looks pretty yucky. However, it will simplify. First, pay attention to the denominator, where I apply the multiplicative inverse. First, I convert the 20 into a fraction. Then, multiply straight across. Any number divided by itself is 1. Therefore, the denominator of the answer becomes 1. This is the second part of our unit rate. Now, simplify the numerator. To do this, I convert the 5 into a fraction, then multiply across. Next, I divide the numerator by the denominator. Because I am really working with a rate and not a fraction, I use the decimal result, 25 hundredths. The unit rate for Kaji's 5-mile ride is 25 hundredths miles per minute. Before I begin with Rania, notice the last step I performed. I divided the original numerator of 5 by the original denominator of 20. While all the other steps occur mathematically, the actual result is the same as dividing the first part of the rate by the second. Let's use this knowledge to jump straight to the answer for Rania. She traveled 8 miles in 25 minutes. 8 divided by 25 is 32 hundredths. This means that Rania's unit rate is 32 hundredths of a mile per minute. Now I can compare the two rates because their units are both out of 1 minute. 32 hundredths is greater than 25 hundredths. Rania was faster than Kaji. To convert a rate to its unit rate form, divide the first value of the ratio by the second value. Remember your units. An answer of 32 hundredths does not make sense for Rania's speed, but the solution of 32 hundredths of a mile per minute does. Notice that when we use a unit rate, we do not specify that the second unit is 1. While it is acceptable to say 1, most will speak and write unit rates without the 1, as in 5 miles per hour or $5.29 per gallon. If you know the unit rate, you can also solve problems involving scaling. In these cases, multiply the unit rate by the number of times it occurs. For example, assume that both Kaji and Rania will ride for 30 minutes at constant rates of speed. How far will each ride? To find out how far Kaji will ride, multiply his speed of 25 hundredths by the time of 30 minutes. 25 hundredths multiplied by 30 is equal to 7 and 5/10 miles. For Rania, multiply 32 hundredths by 30 for a result of 9 and 6/10 miles. In my mathematical world, I have one little problem. I am trying to get some laundry done, and unit rates are everywhere when it comes to the laundry room. A large laundry detergent bottle usually costs $12.97 for 92 fluid ounces. What is the cost per unit? This week, one of the smaller sizes of laundry detergent is on sale. The 42 fluid ounce bottle is $5.93. Is this cheaper or more expensive than the regular price for the 92 fluid ounce bottle? Something called shrinkflation happens to a lot of grocery products. Shrinkflation is when packaging sizes shrink as companies offset costs without dramatically changing the product's price. My laundry detergent has suffered from shrinkflation. The new packaging is 86 fluid ounces with a new price of $12.12. Is this cheaper or more expensive than the original 92 fluid ounce bottle per fluid ounce? Bleach is $6.99 for a 60-ounce bottle. The smaller size of 32 ounces is on sale this week for $3.75. Which bottle is a better buy based on the cost per ounce? Softener sheets for the dryer used to come in a box with 120 sheets for $8.95. The package size has shrunk to 110 sheets for $8.27. Is the new price cheaper or more expensive per dryer sheet? How much did the price change per sheet due to shrinkflation? If I average 1.4 loads of laundry daily, how many loads should I expect to do in November? Take a look and you will see a mathematical world around you filled with rates. Unit rates allow us to quickly make comparisons as well as use the relationship between the values for adjusting scale. Remember that while in practice, we divide the first part of the rate by the second part to get the unit rate, we really create an equivalent fraction using algebraic properties. Working with rates and unit rates is an everyday occurrence for many because we love to make comparisons and use relationships to describe and understand the world around us.